Hey everybody, welcome to session 5 of the Unity Study Jam. In this session, we'll be discussing lighting and camera. So in this session, we'll first start off by looking at what the main camera is and then move on to the lighting system. So basically, the aim is just to make sure your game is better in terms of the user perspective, or how you should think of your game from your user perspective. So that is where both main camera and direction light come in. You might be thinking that these are very inconsequential or small, but this is what decides how your game transforms as a good output. So the main camera basically captures your surroundings and your environment. Whatever is there around you, that gets captured in the main camera. And the direction light determines how much lighting should be there, and also how much of your game is even actually visible to people. So without both of this, you might not have aesthetics, but even before that, you might not even have a properly visible game. So it's very important. They are not very tough concepts per se, but it's important to know how they work. So let me start off by going into the main camera. And before that, now that we have started learning about main camera and all of that, from this week onwards, the end of every session, we'll have like a time lapse of us building our video, or the video of like our game. So if you want to follow along, then you might have to slow it down a bit and watch that portion to build the game like we are doing it. But if you want to get creative, you can always use the video as a reference and build your game. So the last 15 minutes or something of the video will be dedicated to just us building our game and a time lapse of it, but there won't be any explanations for it, just so that you can understand the workflow. Now that that's out of the way, let's get into the topic. So the main camera, it basically captures everything that's in its range. It's just like how normal cameras work, or your eyes, whatever is visible, that gets captured. So this box over here displays the view of your camera basically, or the field of view. So it's actually not a 2D space, but rather it's this 3D area. So this is the place within which if you place your objects, characters will be captured. So now let's just test it out by adding one object. Let me add a cube. So the thing is, it won't be visible in your camera now because it's both your objects are in the exact same position. So that wouldn't work. Let's just move it a little bit further. But even then, the object is not visible. That's because the object is actually very small for your camera to even capture. So let's just increase the size of the object a bit. It's barely visible in your camera right now, so let's just increase it a bit more. Yeah, now that's better, you can see it. So let's just move it a bit closer to the camera, that way it will be easier. Yeah, so that is basically the field of view. So watch this now. I'll place this here, go back to the main camera, and it's still visible because it's inside the range. Now let me drag the cube outside, and it's not visible anymore. When it crosses its range, it wouldn't be visible anymore. So that's the point where it's visible to some extent, and then beyond that, it doesn't get captured. So that's the basic essence of how the camera works. With this, you might be having one question though. Now your characters are not going to be staying still, and they're going to keep moving, and we just learned how to do that as well. But the problem is, right now your camera isn't moving, and you can't make it move exactly, or you can't make animations for it because you might have various different characters and you want to capture different things. So what would you do then? So you want everything to be within a particular range as well. Now for that, let me just show you what I'm saying. So we had done an animation before, this new animation. Let's just modify it a bit, where it's moving in one direction for a long time, so let me make this as 100. So right now it will basically be moving only in one direction. Let's make this 0 as well. So I just wanted to move along the z-axis actually. Okay, so at 0 I wanted to be at 0, and then head over to 60, and I wanted to be at 100 now. So let's just change this to 100. So right now we want the cube to just move in the z direction, and for that we need to first add this animation clip to our object. So we saw the one way we could do it last uh, session, or the one before that, but there's another way you can do it. So when you go to your inspector window, first click on the object, go to your inspector window and add animator. So the idea is that once you add an animator controller to your object, and it will start following that object. That's the basic criteria. So the animator controller that we had was basically this one, and the animation was what we had created. So let me go back to the object and then add the controller over here. Right. So now when I keep the main camera here, let me bring this a bit closer. Okay, so it's kind of visible now. So the thing is, the cube is at position 835 already, so we have to make it move beyond that. So we need to fix that one right now. So we'll go back to, and we want it to be beyond range, so let's not make it 100, let's make it 1000. So from 0 I want to make it go to 1000. So that I can show how the clip moves from starting to end. So now what I'm going to do is play the game. As you can see, the object is moving, but your camera is going to stay in one position. So naturally, if I had set a longer distance, it wouldn't be in the frame anymore. So what if this is the state of your character? It keeps moving on and you can't follow it. Now that is why we're going to find a small solution to this. Instead, what we'll do, there's two ways you can think about this. So you would have heard of first person point of view, third person point of view, and all of that. So what we'll first try to do is the camera will follow your object. So wherever your object is moving around, you want your camera to follow that. So the best way to do that is use something called the parenting concept. So when I drag the camera and place it into the cube, the camera will do everything that your cube does. It will follow the same thing. So it inherits the properties of the cube in some sense. So if you play this now, as you can see, you can't observe any difference because your camera and your object are moving together. So you won't see the difference you saw last time, but it's actually moving. It won't be visible here, but it's actually moving. So this is the kind of thing that you want to achieve. So what you would do is make your character look like it's moving, but then it should also follow exactly what your character is doing, especially when your character is having directions, moving right, left, and all of that. This is very important. This is one thing we saw, but there's another way to actually do this. Basically, what you could otherwise do is increase the size of your cube a little bit more, and then actually place your main camera inside the cube like this, which means you will be looking at the world from the cube's perspective. So it's basically like putting or showing how the environment looks from your character's perspective, and the character actually itself won't be visible. So when you run that also, again you can't see any visible changes here since we don't have an environment also. Oh, then you have to parent it. So again, parent it by dragging it. So basically the cube is a parent to the main camera now, and then I'll run this one. So this is how it works. So this is called first person point of view. So these are the two ways you can actually think about your camera moving. With that understood, you might have to think about how you want your game to work. Or another thing that you could actually do is, instead of animating the cube, animate the main camera itself and put the cube inside the main camera. So this way you will give you're considering the main camera as your person and just assigning the cube to the main camera, that's all. So what you would do is, instead remove the animator over here, go to the main camera, add component animator, and then just drag and drop this one. So the difference right now is the cube will move because of the camera, not the other way around. So this is the idea behind animator. This will be useful when you're adding scripting also, when you want to keep your character in the front and it has to probably keep running. The environment will stay static, your character will be the only thing that's moving, and then your camera is the one that has all the animations that's actually moving, and then your object will, or your character will just follow the camera, and the scripting and everything is attached to your main camera actually. That is one way you can approach how the characters move. So these are both the approaches you could do. So parenting is a very very interesting concept to use. So whenever you put something under another thing, it means it gets all the properties of the original one. So if you understand the small nuance, then you can actually make a nice game out of this. We will actually use this concept in our own game in the next week, in the end of the videos which I had mentioned earlier. So we'll do that next week. So that is the first idea. Moving on, we'll talk about lighting. So just like how you can't see what's there in a dark room, similarly you need lighting for things to actually be visible on your camera. So let's just imagine that I don't have the light for now. This is how your scene would actually look. Even then over here it's visible to some extent, but in general this is how your scene would actually look. So what I will do now is just explain a little bit about the different types of light you have here. So first one was the directional light which we had seen earlier. So directional light is more like the sun, in the sense that it basically adds lighting for a very large space. So when you actually see the sun, it doesn't work like I'm going to only go to this particular small area and going to provide lighting for that particular place. Instead it covers a broad area, and it generally, so when you look at the sky right now, you'll only see a portion of it and how it looks. This is similarly how it works here. The most interesting thing about directional light is how you can change the lighting by changing the direction, just like your sun, or rather the rotation. So when you keep rotating, you can actually see the different phases of this. So this is the most important thing. It becomes bright up to a point, reduces in brightness, goes into night mode, and then comes back out again. So this is what directional light is. As you can see, if you consider that as the horizon, you can see how the lighting is actually changing. This is how your object would look right now. It will be pitch black, the places around it. So that is what directional light does. If you want to give an overall theme to your game, so if you want it to look like an evening or something, you could do this. So that is where directional light would help. So we'll remove that now. Let's say the next option is actually point light. So how the point light differs is, as you can see, adding the point light didn't change how the surroundings look. So when I add a point light, it makes only a small portion of it visible. So for comparison, take the entire sun and take a bulb. How would they differ in lighting? A bulb can only cover a very small portion of an area. So that is basically how point light works. So even now you can't even see the effect of the point light, and that is what you can adjust over here. So this is the range as in how far it is visible. Intensity refers to the strength actually. So if I make this 100 right now and then increase its range also a bit, and then I bring this to the top of my cube. Okay, and then move it a bit more closer. Okay, so the camera is on the other side, so move it over there. Even then you can't see its actual effect, so what I'm going to do is increase it even more and then increase its range as well. See, this basically covers a very small portion of your lighting. As you can see, this is the range which it covers. So this is basically the point light. As you can see, it's just a point, the space it covers. That's why it's called a point light. The very interesting feature about the point light is the color varieties that you can actually provide. You can make very cool effects in your game with this actually, and adding colors will actually add a theme to your game and all of that. So this is extremely helpful to keep in mind. So you can add these kind of colors. So that is basically the concept of point light. These are the two most widely used lighting systems in Unity actually. The other two are spotlight and area light. Again, just to show how spotlight works, we'll adjust these values first. Spotlight and obviously the radius it covers. So with the spotlight you can actually determine which particular area you wanted to cover. So if you would have seen spotlights in real life actually, they start from a small point and then they actually work like a cone and it covers a small circle of an area. So that is the idea behind spotlight, and this is basically just an implementation of that in Unity. So if you want to see the actual working, let's rotate the light. Rotate the light in this direction and then move this a little bit. And then there you go, that's your spotlight. When you want to just highlight a particular area for lighting, you would use a spotlight. How is different from point light is, so for example, when you want to use point light somewhere, it would usually be to add more lighting. For example, let's say you want to show like tube lights and all in your game, or rather you want to show street lights. You would have a street light model, but that might not have any lighting on its own. So at that point you would just put your point light over there and that would be visible. So the difference would be that the point light would be visible on more directions, on all the directions. The spotlight is only confined to be visible in this particular direction. So that is the spotlight. So the next one we have is actually area light, and even with this I'm going to show you a small thing. Let's just try doing this and then change its intensity to 1000. But then the effect of this is actually not even visible. As you can see, for the other things you were actually able to see a light, but right now it's not even visible. The thing is, area light isn't used very often as compared to the other three, but then it's a small challenge for you to find out why this is not working and get the fix of it. It's almost available in all the documentations and websites. So it's just a small challenge. You need to make a small change in your settings. The hint is basically there's a small change you need to make in your settings, and it's because of that it's not working. Test it out and see if that works. That's why we've not covered area light. But then if you want to know the concept behind area light, it's basically that it emits light from this particular rectangular source and in all directions, and it's not similar to your point light or even your spotlight, because it can have various sources. That's the idea behind area light. So try exploring why it's not working and how to make it work. That's a very interesting thing to check out. So with that, we come to the end of the main topic for this session, which was main looking at main camera and also understanding about the various types of lighting systems. And with this, we can start actually implementing all these concepts in our game slowly. So after this, you'll be looking at the time lapse of how we are building a portion of the game. So if you want tips or suggestions, you can watch that, or just skip through it and try to even follow your own game or your own ideas. So that's the end of this.